Another AC analysis. This is example 3. This is the voltage divider bias circuit that we did before. First thing you do is you draw the AC equivalent circuit. You short out the DC supply, so you short out the 18 volts. That puts this resistor. If this goes to ground, then this resistor and this resistor are in parallel, which is shown here in the AC equivalent model. Then you transfer the parts over one by one. So I would take this part and put it there between these 2 points. This one here between the base and ground. You transfer the points one by one. I usually do this. I leave the transistor for last, so I just leave an empty box for the transistor. And then when I get all the other parts, I put a T model in the box. I solve for R prime E, and I write that value down there. R prime E is 25 millivolts over the DC emitter current. Comes up to about 3.5 ohms. Once we've got all the values down on the AC equivalent circuit, we can use that to find Z in and Z out by Thevenizing. So Z in, if I look into this circuit, I have 2 resistors here and they're in parallel. So it's RB1 parallel to RB2 parallel to this third branch, which is multiplied by beta plus 1 to bring it over to the base side. Put the numbers in, comes out to 11.8 K. Z out, we stand here and we Thevenize looking back into the output, and that comes out, that leaves us with RC, which is 1K. Solving for AV, V out over V in. The circuit is actually, these 2 parallel resistors make no difference to the voltage gain because that's done on this side. So the formula is going to be exactly the same as it was for the emitter stabilized bias circuit. Identify the nodes, the pieces of a wire. There's V in, there's V out. Write equations for V out and V in using transistor currents and impedances. So V out, currents going back and forth. IC/RC, this is done open circuit, no load attached. V in would be the current going back and forth between these 2 guys, which is IE, R prime E plus RE. Take IC and IE and replace them with multiples of the base current. Cancel out the IB, put in your known values, crunch, crunch, crunch. So get everything in terms of IB, cancel out the values, enter the known values, come up with a gain of -3. And then we can substitute these 3 values. So this one, and this one go on the 2-port model of the amplifier. 11.8 K is Z in, 1K goes to Z out, -2.97. That's the gain of the dependent voltage source.